Hello, welcome to this module on Distribution Line Components Part 1. Let's start with the topic on poles, different types and heights. At the end of this topic, you will be able to define pole, describe classification of poles, explain protection of steel poles, explain different types of cement poles, list application of PSC pole, understand the standards for PCC or PSC poles and steel poles, explain type tests, explain acceptance tests, describe routine tests. Let's start off with the poles. So, what are poles? The support by means of which conductors etc. of overhead lines remain suspended above the ground is known as electric pole. The poles or supports are classified according to the material used for it. Steel, rail poles and tubular poles, cement, RCC poles and PSC poles, wood. In the previous topic, we have learnt what poles are. Now let's learn various types of steel poles in detail. Steel poles are used in large quantities for distribution lines in urban areas. These can be of L-shape rail type and tubular shape and are light in weight and cheaper in cost. These are normally used for 33 kV lines. Tubular poles are either of swaged section, built-up sections, or stripped single unit type joint-less one casting. These are normally used in hilly areas. RSJ pole or rolled steel joist are structural members specifically manufactured for use as electricity poles. These poles have long life, strength and sturdiness. These poles are ideal for use in the coastal area, hilly areas, railway crossings, river crossings, etc. Let's discuss steel pole protection. Steel poles are generally exposed to atmospheric conditions such as light, rain, pollution, etc., which may reduce their strength and damage the poles. Steel tubular poles shall be coated with black bituminous paint conforming to IS 158-1968 throughout, internally and externally, up to the level which goes inside the earth. The remaining portion of the exterior shall be painted with one coat of red oxide primer as specified in IS 2074-1979. The hot rolled steel beams shall be coated by hot dipped galvanization as per IS 2629 for coastal area and mild steel for rest of the areas. Moving on, let's learn various types of cement poles in detail. Concrete poles are used for LT and 11 kV distribution lines. RCC poles are made by reinforcing, that is, embedding steel rods into concrete slabs of pole-shaped cylinders. These poles have a long life, remain unaffected by rain, sunlight, etc. and are heavy in weight due to the presence of concrete and steel. PSC poles are made by reinforcing pre-stressed steel wires and by pouring concrete into the mold and compacting it with a vibrator. PSC poles are suitable for use in overhead 11 kV and LT power lines and double pole structures for 11 bar 0.4 kV substations. Pre-stressed poles are lighter and stronger and they require less reinforcing steel. The principle behind pre-stressed concrete is that compressive stresses induced by high-strength steel tendons in a concrete member before loads are applied will balance the tensile stresses imposed in the member during service. The magnitude of pre-stress required is half that of the normally provided for bending in one direction. Pre-stressed concrete poles are designed as members with uniform pre-stressing since they have to resist equal bending moments in opposite directions, which is not the case for other pre-stressed structures. Now let's discuss the application for PSC pole having 7.5 meter 8 meter and 9 meter length. Its applications are as follows. 7.5 meter PSC poles, 11 kV lines without earth wire, LT lines horizontal formation. Reference to REC construction standards A4B5. 8 meter PSC poles, 11 kV lines with earth wire LT lines vertical formation. Reference to REC construction standards A5B6. 9 meter PSC poles. These poles shall be used for double pole structures of distribution transformer as per REC construction standards F1 to F4. For special locations in 11 kV and LT lines such as road crossings, etc. Let us understand the standards for PCC, PSC poles and steel poles. Standards for PCC, PSC poles. IS 1678-1998 specification for pre-stressed concrete poles for overhead power and telecommunication lines. IS 2905-1989 methods of tests for concrete poles for overhead power and telecommunication lines. IS 7321-1974 Code of Practice for selection, handling and erection of concrete poles for overhead power and telecommunication lines. Steel tubular poles. IS 2713 Part 1 3 1980. RSJ poles. IS 2062-2011. IS 808 1989. IS 1852-1895. Let's learn the minimum specifications for PSC poles. This is the detailed image of PSC poles. IS 1678-1978. Length of pole, factor of safety, grade of concrete, working load, diameter and number of pre-stressing wires, concrete quantity per pole, clear cover to wires, location of holes. Let's learn the specifications for steel tubular poles. This is the detailed image of steel tubular poles. Applicable IS 2713 Part 1 3 1980. Length of pole, type of pole, planting depth, working load, approximate weight of pole, point of application of load, breaking load, finish. So, the different type of tests are type tests, acceptance tests, routine tests. Type tests are generally performed on any equipment conforming to relevant national or international standards to validate the design and to demonstrate its functional requirement meeting the intended application and reliable performance during its service life. The following are the type tests for different types of poles. PSC poles, verification of dimensions, measurement of cover, traverse strength test. Steel tubular poles, verification of dimensions, tensile test, deflection test, permanent set test, drop test. RSJ poles, dimension test and weight, kilogram per meter, mechanical properties, tensile strength, yield stress, percentage elongation, bend test, test in respect of hot dip galvanization, freedom from defects. Factory acceptance testing FAT helps verify that newly manufactured and packaged equipment meets its intended purpose. The FAT validates the operation of the equipment and makes sure the specifications and all other requirements have been met. Routine tests, as the name implies, are tests carried out on every equipment manufactured. They are done to verify if component or system meets specifications in terms of performance. Pole transverse load test. Transverse loading is a load applied vertically to the plane of the longitudinal axis of a configuration, such as a wind load. It causes the material to bend and rebound from its original position, with inner tensile and compressive straining associated with a change in curvature of the material. Transverse loading is also known as transverse force or crosswise force. So, determine the behaviors of pole under transverse loading. This test is conducted as pole in field will face wind load and stringing load, which will create tension and compressive straining it. The following are the terminologies to be known before going into the test. Transverse, the direction of the line bisecting the angle contained by the conductor at the pole. In the case of straight run, this will be normal to the run of the pole. Transverse load at first crack. For design, the transverse load at first crack shall be taken as not less than the value of the working load. Working load, the maximum load in the transverse direction that is ever likely to occur, including the wind pressure on the pole. This load is assumed to be at a point 600 mm below the top, with the butt end of the pole planted to the required depth as intended in the design. Ultimate failure, the conditions existing when the pole ceases to sustain a load increment owing to either crushing of concrete or snapping of the pre-stressing tendon of permanent stretching of the steel in any part of the pole. Ultimate transverse load, the load at which failure occurs when it is applied at a point 600 mm below the top and perpendicular to the axis of the pole along with the transverse direction, with the butt end of the pole planted to the required depth. The tools shown on the screen are required for the test. They are dynamometer, steel scale, chain pulley block, wire ropes, measuring tape, deflection reader. The table shown are sampling of the transverse load test. There are three criteria in which pole shall be passed, which are as follows. No visible crack shall be appearing on or before working load of pole. That is, a pre-stressed concrete pole shall be deemed not to have passed the test if the visible crack appears at the stage prior to the application of the designed transverse load for first crack. Permanent deflection of the pole should be within acceptance criteria, that is 1 mm per meter length of the pole. Observed transverse load should be equal to greater than designed ultimate transverse load. That is, a pre-stressed concrete pole shall be deemed not to have passed the test if the failure of the pole occurs before the designed ultimate transverse load. Let us see the procedure now. Transverse load test procedure. Poles shall be tested after completion of 28 days of curing period. Test bench is established in the factory on ground with rigid support at the bottom end. Intermediate rollers are provided at 4 meter as required to reduce the friction in movement. Pole is laid in horizontal direction on the test bench and butt end at a distance equal to the depth of planting for 1.5 meter for 9 meter pole. Deflection meter and dynamometer are connected to digital monitor and both are calibrated to 0 value before applying the load. Tension load shall be applied at point 300 mm from top of pole through chain pulley block arrangement and gradually increased to the design value of the transverse load for the first crack. Initial load shall be gradually increased to working load and held for 5 minutes. At each stage, load shall hold for 5 minutes and hair cracks and deflection observed and noted. When load reached at working load, after holding for 5 minutes, load shall be released to 0 and permanent deflection is noted. If no crack is observed at working load and permanent deflection is an acceptance criteria, then pole has passed two criteria of test. Now pole shall be checked for ultimate strength test. Load is slowly increased to working load plus 10% of the minimum ultimate transverse load held for 2 minutes and hair crack deflection reading are observed and noted. Same procedure shall be followed till load reaches ultimate transverse load value and thereafter load until failure occurs. Each time load is applied, it shall be held for 2 minutes and hair crack and deflection should be noted. If pole does not break a designed ultimate transverse load, then it has passed the ultimate strength test also. After that, all arrangement can be dismantled and report can be prepared and signed by site engineer, consultant, manufacturer and client. Here are some of the images that are taken during the test.